Good morning, friends. In the previous lecture, we were solving about the 7th chapter, the coordinate geometry. Now, friends, in this lecture, we are going to start with the next chapter, chapter number 8, that is Introduction to Trigonometry. Friends, before starting with this chapter, you need to know that what trigonometry is, right? So, trigonometry basically, it is the relation between the lines, or you can also call it as the sides, and the angles of any triangle. A relation between the sides or lines and the angles of any triangle is explained in the term trigonometry. Right? So basically you need to know that whenever we come with the terminology that a trigonometry, at that time the first thing that must come to your mind is a triangle. Is it clear? So trigonometry basically always deals with a triangle. Now, to understand this topic, introduction to trigonometry, we are going to use only and only the right angled triangle. Right angled triangle. Now you must know what is a right angled triangle. Right angled triangle, that means any one of the angle is 90 degree. 90 degree, that means it is called as the right angled triangle, and the side opposite to 90 degree is called hypotenuse. Right? This is the right angled triangle. So this is the basic description of a right angled triangle, that any one of the angle is 90 degree and the side opposite to the 90 degree is known as the hypotenuse. So in this topic, in this chapter, friends, we are going to maximum deal with the right angled triangles only. Right? So let us see what the topics in this chapter are covered, and then we shall move on to the topics one by one. So in this chapter, friends, you are going to learn about the trigonometric ratios, then the trigonometric identities, then the trigonometric ratios for complementary angles, and the trigonometric values at specific angles. These are the 4 topics that we are going to study in this chapter: the trigonometric ratios, trigonometric identities, trigonometric ratios for complementary angles, and the trigonometric values for some specific angles. Is it clear? So basically, friends, this chapter is the most important chapter of this standard, and also this will be helpful for you for the upcoming years, that means in the 11th standard and 12th standard. So basically you are going to learn most of the things related to the trigonometry here itself in this chapter, and in the further standards you are going to learn about the application of this trigonometry. Okay, now let us start with the very first topic, that is trigonometric ratios. So friends, as you know what the ratios are, right? We already know what the ratios are. Trigonometric ratios. Ratios basically means, what does this ratios mean? Ratios basically means there is a term like numerator and a denominator. right? And when we write down this in the form of numerator and denominator, numerator upon denominator, that becomes a ratio. Ratio, this word is used to find out the rational numbers which are denoted in the form of P by Q. So this rational numbers are again denoted in the form of a ratio P by Q or P upon Q, and that again comes from the word ratio, right? So that is about the trigonometric ratios. Now friends, in this topic trigonometric ratios, let us see what the things are being included. So first of all friends, I would like to draw a right angle triangle here. A right angle triangle ABC. This is my A, B being a right angle, and C. This right angle basically means 90 degrees, right? So that is my right angle triangle that I am going to use here, right angle triangle ABC. Now the side opposite to 90 degree, that is known as the hypotenuse. If I say this as my ideal angle, angle C, then this AB, that is known as side opposite to angle C, and this is known as side adjacent to angle C. Adjacent, that means near, and opposite, that means opposite to or far away from that. So this is our ideal angle, angle C, and this is AB, that is the side opposite to angle C, and BC is the side adjacent to angle C. So here from this figure, if I write it down like this, then will this create any doubt to you that rather than writing down in the figure, let us keep it neat and tidy. Here AB, that is equals to side opposite to angle C. BC is the side adjacent to angle C, and AC is the hypotenuse, right? So these are the three terminologies that comes from this triangle if we have taken C as our ideal angle. Now if we take angle A as our ideal angle or our reference angle, then the things will be reversed, right? This is for C as our reference angle. So if we take C, then AB, that is the side opposite to angle C, BC, that is the side adjacent to angle C, and AC, that is called the hypotenuse of the triangle, right? Now coming to the ratios, friends. So ratios basically are, there are 6 different ratios that we use here for the angles either of A or either of C. So first of all, if we are taking for angle C, then we will get 6 different ratios for each of them, and that comes to us as sine of angle C, basically denoted by, let me write it down like this, that sine, the first ratio, sine of angle C, basically denoted as sin C, is given by the side opposite to angle C divided by the hypotenuse. This ratio, that is sine of angle C, denoted basically as sine C, is given by side opposite to angle C upon hypotenuse. So what is side opposite to angle C? AB. And what is the hypotenuse? AC. So this is given as AB upon AC, right? That is the trigonometric ratio for sine C. So basically friends, now sine C, that is equals to AB upon AC, right? Sine C equals to AB upon AC. The second ratio, that is the cosine of angle C, written basically as cos C, is given by the ratio cosine of angle C, written as cos C, is given by the ratio side adjacent to angle C upon the hypotenuse. Right. Now friends, what is the side adjacent to angle C? That is BC, and hypotenuse we already know, that is AC. So that gives me BC upon AC. So the ratio of cos C, that is given by BC upon AC. Right? BC upon AC. Now, in the third thing, the third function that we have, the third ratio that we have is the tangent. Tangent of angle C. Tangent of angle C basically friends, that is tan C, or it is written as tan C. Basically written as tan C. It is given by the ratio, that is side opposite to angle C upon side adjacent to angle C. So side opposite to angle C upon side adjacent to angle C. What is opposite side or side opposite to angle C? AB. Side adjacent to angle C, BC. So that gives me AB upon BC, and hence the ratio is given tan C equals to AB upon BC. So we got the third ratio here, that is tan C equals to AB upon BC. Right. So these are the three ratios friends that we got from this triangle here. The first one, again let me recall this. The first one is sine of angle C, written as sine C is side opposite to angle C upon hypotenuse, that is AB upon AC from this figure. Similarly, cosine of C, written as cos C in short form. This is the full form, cosine. In short, it is written as cos. So cosine of angle C is written as cos C, is side adjacent to angle C upon hypotenuse, which is BC upon AC from this figure. Now the third one, that is tangent of angle C. Tangent, that means tan C is side opposite to angle C upon side adjacent to angle C, which is given by AB upon BC. Right. So these are the three basic ratios. Now we are going to see the fourth one, that is cotangent. Cotangent of angle C, in short written as cot C. Cot C. That gives me the ratio. This ratio here friends, cotangent of angle C, is exactly inverse as that of the tangent of angle C, that is side adjacent to angle C upon side opposite to angle C. See, in tangent of angle C or tan C, we had side opposite to angle C upon side adjacent to angle C. Now, here in this we will be having side adjacent to angle C upon side opposite to angle C, and that gives me BC upon AB. So, basically you can write down the ratio as cot C is equals to BC upon AB, which gives me my fourth ratio, that is cot C equals to BC upon AB. Right? That is my fourth ratio here, friends. The first one again, sin C, that is side opposite to angle C upon hypotenuse, cos C, side adjacent to angle C upon hypotenuse, tan C, side opposite to angle C upon side adjacent to angle C, cot C, that is side adjacent to angle C upon side opposite to angle C. The fifth one, now I am having, that is secant of angle C. In short, it is written as sec C. Sec, S-E-C, sec C, that is equals to hypotenuse upon side adjacent to angle C. Friends, you can see here that hypotenuse upon side adjacent to angle C, that is equals to secant of angle C, and cosine of angle C was side adjacent to angle C upon hypotenuse. So basically the second ratio and the fifth ratio are exactly inverse of each other, as we seen for the third and fourth one, right? So third and fourth are inverse of each other, second and fifth here are also inverse of each other. This is given hypotenuse, that is equals to AC upon BC. So in short, friends, it is written like sec C is equals to AC upon BC, and that is my fifth ratio of the secant of angle C. Right? Sec C is equals to AC upon BC. And last one, for the last ratio, that is cosecant of angle C, which is shortly written as cosec. Cosec C. It is written as cosec C. Cosec C, given by the ratio that is equals to hypotenuse upon side opposite to angle C. So you can, friends, see here that now the third and fourth were relatable, they are inverse of each other. Second and fifth were relatable, they are again inverse of each other. And look at the first and the sixth one. Cosecant of angle C is hypotenuse upon side opposite to angle C. Sine of angle C is side opposite to angle C upon hypotenuse. So you can say that the first one, that is sine of angle C, and cosecant of angle C are both inverse of each other, and hence we get the ratio as AC upon AB. So that gives me shortly cosec C is equals to AC upon AB. That is my sixth ratio, and hence these are the six ratios that we get for this triangle ABC, having angle B as 90 degree and angle C as our reference angle. Right? So again, let us quickly discuss what are the trigonometric ratios that we got from this triangle. That is the first one, Sine of angle C, that is sine C, is equals to side opposite to angle C upon hypotenuse, which is written as AB upon AC. That means sine C is equals to AB upon AC. The second one, cosine of angle C, that is written as cos C, is side adjacent to angle C upon hypotenuse, written basically as BC upon AC. So directly cos C is equals to BC upon AC. The third one, tangent of angle C, that is tan C, is written as side opposite to angle C upon side adjacent to angle C, that is AB upon BC from the figure. So directly we can write it down like tan C is equals to AB upon BC. Okay. The fourth ratio, friends, cotangent of angle C, that is cot C, is side adjacent to angle C upon side opposite to angle C. So friends, from these two, the tangent of angle C and cotangent of angle C are relatable. That means tangent and cotangent are exactly inverse of each other. So cot C can now be written as BC upon AB. The fifth one, friends, secant of angle C, that means it is shortly written as sec C, that is hypotenuse upon side adjacent to angle C, that is written as AC upon BC. You can relate this secant of angle C with cosine of angle C, that is side adjacent of angle C upon hypotenuse. So cosine of angle C and secant of angle C are inverse of each other. Hence you can directly write down like sec C is equals to AC upon BC. And last one, friends, cosecant of angle C, that is hypotenuse upon side opposite to angle C, shortly written as cosec C, that is AC upon AB. Again, this cosecant of angle C and sine of angle C are both relatable because they are exactly inverse of each other. Hence cosec C directly is written as AC upon AB. Right? So these are the 6 different ratios, friends, that we get from this triangle. Here, friends, one more thing I would like to add here, that the reference angle, here this reference angle, angle C that we have taken, will be an acute angle, right? Because if this becomes an obtuse angle, then this triangle will no longer be a right angle triangle, right? Because right angle triangle, the property of a right angle triangle is any one of the angles is 90, and the other two angles, the other two remaining angles must be less than 90 or acute angle. So here angle C must be an acute angle so as to perform these 6 different ratios, right? So these are the 6 ratios that we got here from this triangle. So first of all, friends, I would like you to mention this down, and then I shall give you 3 different ratios that relates these to each other. Okay. So now let me erase this triangle here. Now as we see here, these are the 6 different ratios that we have got here. So the extra thing that we need to understand, that is sine C, that is equals to 1 upon cosec C, or cosec C, that is equals to 1 upon sin C. As you can see that these both sin C and cosec C are inverse of each other. That means sin C is 1 upon cosec C, or cosec C is 1 upon sin C. The second thing you need to learn or you need to understand, that is cos C is equals to 1 upon sec C, or sec C, that is equals to 1 upon cos C. Right? So this is the second ratio that you need to understand, that sin C is equals to 1 upon cosec C, or cosec C equals to 1 upon sin C. Cos C is equals to 1 upon sec C, or sec C is equals to 1 upon cos C, and the third one, tan C is equals to 1 upon cot C, or cot C is equals to 1 upon tan C. Right? So these are the three different ratios. They are relatable to each other. They are relatable to each other from these 6 different basic ratios, which are a must to remember. So again, let us quickly see that sin C is equals to 1 upon cosec C, or cosec C is equals to 1 upon sin C. The second one, cos C is equals to 1 upon sec C, or sec C is equals to 1 upon cos C. And the third one, tan C equals to 1 upon cot C, or cot C is equals to 1 upon tan C. So these are the 6 different ratios, friends, that we need to understand from this first triangle that we have seen here. So these are the ratios. Just take a look over it, and I insist you that you will note this down somewhere in a book. So this must be clear now, right? Now friends, after seeing that what the trigonometric ratios are, we will see how we can obtain these trigonometric ratios when you are given a real example. So let us see one of the examples here, that I have a question. In triangle ABC, the first question I am having, in triangle ABC, angle B is equals to 90 and sin A is equals to 1 upon 3. Find the remaining ratios. You need to find out the remaining ratios. So we will first of all see that how this figure is obtained. In triangle ABC, angle B is equals to 90 degrees. So first of all, we will draw a triangle ABC with angle B as 90. So this will be B, because this shows me 90 degree here. And you can take A and C anywhere. If you take A, then here it will be C. If you take C here, then there it would be A. So let me take A here, and this is my C. Right? So I got the triangle ABC, and we are given that sin A here, sin A is equals to 1 upon 3. Here, given that sin A is equals to 1 upon 3. So friends, what does this sin A equals to 1 upon 3? This 1 upon 3 here is the ratio, right? And we cannot say that this is my 1, that means any of the side will be 1 and any of the side remaining will be 3. No, it is not possible. So first of all, we need to take out this ratio, that is equals to K. Let or say this is equals to K. Therefore, or let me write it down like this so as you can understand. Given that sin A is equals to 1 upon 3, that is equals to side opposite to angle A upon hypotenuse. Now, can you directly relate that side opposite to angle A will be 1 unit and hypotenuse will be 3 units? No, you cannot directly relate. So, what we are going to do is we are going to take a proportion here that is equals to K. Say this ratio is equals to K. Therefore, now we can say that side opposite to angle A is equals to K and hypotenuse is equals to 3K. So friends, whenever you are solving this kind of examples, when you are given a ratio, a triangle and you need to find out the remaining ratio, at that time you will always suppose this thing for taking out the ratio to the proportion. So now we can directly say that side opposite to angle A, this is my angle A here. So side opposite to angle A, BC. Therefore, BC equals to K and AC is equals to 3K. So this will be now K, this will be now 3K. Is this thing clear or not? Right? You can directly write it down now that BC is equals to K and AC is equals to 3K. Now to find out the remaining ratios, friends, first of all we will require this side, because we require the side adjacent to angle A also, no? So to find out that here okay, let me write down here itself. In triangle ABC, angle B is equals to 90. So applying Pythagoras theorem, what can you write down? AB square plus BC square is equals to AC square. We are having AB, no, we are not having AB, we are having BC, yes, that is K, and we are having AC, that is 3K. Therefore, AB square plus K square is equals to 3K whole square, which gives me AB square plus K square is equals to 9K square. Therefore, AB square is equals to 8K square and hence AB equals to 2 root 2 into K. Right? Because square root of 8 is 2 root 2. So we got the value of AB, that is now 2 root 2K. Right? AB, that is equals to 2 root 2K. So now you can directly apply the ratios. We are having the ratios, right? And this can be directly applied, that we have seen here. So first, the very first ratio, that is sin A. Friends, sin A is already given, so there is no need to find out the ratio for sin, right? So we will start with the remaining ratios. So the second ratio, that is cosine of angle A. Now the first ratio that we have is sin A, but sin A is already given, so we will find out the second ratio. Now cos A, that is cosine of angle A, that is side adjacent to angle A upon hypotenuse. What is side adjacent to angle A? That is AB upon the hypotenuse, that is AC. This is my side adjacent to angle A, this is my hypotenuse, and this is my side opposite to angle A. So what is AB that we got here? That is 2 root 2K upon AC. AC is 3K, K and K is cancelled, that is 2 root 2 upon 3. So we got the value for cos A, that is 2 root 2 upon 3. Is it clear? So that is how we find out the ratio. So we got cos A, that is equals to 2 root 2 upon 3. Similarly, I can also find out tan A. Tan A, that is side adjacent to hypotenuse? No. Remember friends, whenever you are finding out tan A, at that time you will have the opposite side first and then the adjacent side. So side opposite to angle A, that is BC, upon side adjacent to angle A, that is AB. So tan A is basically BC upon AB, which is equals to K upon 2 root 2k, k and k can be cancelled, which is equals to 1 upon 2 root 2. So we got the second ratio, required second ratio, that is tan A is equals to 1 upon 2 root 2. Right? Let us find out the third one, cot A, that is side adjacent to angle A upon side opposite to angle A, or basically AB upon BC. Friends, see, you can also write it like tan A equals to 1 up, cot A equals to 1 upon tan A, that we have written on this part before this topic or before this example, right? So you can also write it down like that, or if you don't remember that, then you remember the ratio that cot A is side adjacent to angle A upon side opposite to angle A, so that is equals to 2 root 2k upon k, k and k can be cancelled, that is 2 root 2. So the ratio for cot A is 2 root 2 upon 1, or simply 2 root 2. So we got our third ratio. The fourth one that we require is sec A. Again, what is sec A? Hypotenuse upon side adjacent to angle A. So what is hypotenuse here? AC upon side adjacent, that is AB. Again, so AC, what is AC? 3k, and AB is 2 root 2k. So 3k upon 2 root 2k, k and k is cancelled, and that is equals to 3 upon 2 root 2. So we got our fourth ratio, that is sec A is equals to 3 upon 2 root 2. That is the fourth required ratio. And the fifth one, let me write down here, that is cosec A. Cosec A, that is hypotenuse upon side opposite to angle A. So what is hypotenuse here? AC upon the side opposite to angle A, that is BC. What is AC equals to? 3k upon the side opposite to angle is k, k and k is cancelled, that is 3 upon 1, or simply you can write it down like 3. Right? So these are the 6 different ratios. One of them was given that sine A is equals to 1 upon 3. The remaining 5, cos A, that is 2 root 2 upon 3, tan A is 1 upon 2 root 2, cot A is simply 2 root 2 upon 1 or 2 root 2, sec A is 3 upon 2 root 2, and cosec A is 3. Now relate it. How? See, can you find out any similarity between sine A and cosec A? See friends, sine A is 1 upon 3 and cosec A is 3. So, see the values 3 and 1 upon 3, are these two inverse of each other? So, you can say that sine A is equals to 1 upon cosec A. Second one, cos A and sec A. See, cos A is 2 root 2 upon 3 and sec A is 3 upon 2 root 2. Again, they both are inverse of each other. So, you can say that cos A is equals to 1 upon sec A, or sec A is equals to 1 upon cos A, and similar relation between tan A and cot A. So tan A is 1 upon 2 root 2 and cot A is 2 root 2. So again they both are inverse of each other, that means we can say that tan A is 1 upon cot A or cot A is 1 upon tan A. So in this manner friends, you can find out the ratios for different angles that are given to us. Suppose here we were having sin A equals to 1 upon 3. Then we might have some another ratio that is given to us, and we need to find out the remaining ratios for each and every function. Friends, this is about finding out the ratios. So today we learned about the trigonometric ratios, 6 different ratios, and an example to solve how to find out the remaining ratios given that one of the ratio is sin A equals to 1 upon 3. So for today we will keep up to this much, and in the next lecture we are going to solve some more examples related to the trigonometric ratios. Thank you, friends.